Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about voltage source. Okay, so what is voltage source? A voltage source is a device or component that provides a constant voltage regardless of the current flowing through it. Okay, so this type of voltage source is known as your ideal voltage source because the voltage remains constant irrespective of the value of your current. Okay, so let's say this is your Vs plus minus Vs voltage and this is the terminal voltage Vt. Okay, so irrespective of the value of the current I, okay, the value of the Vs does not change. Okay, so it means that there will not be any voltage drop in this particular circuit. So in case of an ideal voltage source, the resistance of the ideal voltage source is your 0. Okay, so the VI characteristic of an ideal voltage source will be like this. It will be a straight line. Okay, so because the voltage is not changing with respect to the value of current. Okay, but but in case of a practical voltage source, there exists some kind of internal resistance Rs. Okay, so there will be a voltage drop across this particular voltage source. Okay, so the equation for a practical voltage source will be V of t, which is the terminal voltage, will be equal to Vs minus I into R of S. Okay, and there will be a drop in the terminal voltage as we will increase the value of the current. Okay, so this particular characteristic or the line depicts the variation of the terminal voltage with respect to the current for a ideal voltage source. Okay, and this line shows the characteristics of a practical voltage source. Okay, so I hope it is clear. So the next one we have is the connections of voltage sources. Okay, so the first we have is your series connection. Okay, so when the two voltage sources, let's say this is your V1 and this is your V2, are connected in series with each other. So as you can see, the polarities of the V1 and V2 are aligned in the same direction. It means that the resultant of these two voltages will be equal to V1 plus V2. Okay, this is the first case. Okay, so in the second case, we can say that, let's say the two voltage sources are connected, have the opposite polarity. Okay, so let's say this is V1 and this one is your V2 with the opposite polarity. So the resultant voltage will be equal to plus minus, which will be equal to V1 minus V2. Okay, so I hope it is clear how. So in case of series, the voltages with same polarity adds up, and if they have an opposite polarity, then the resultant voltage will be the difference of these two voltages. Okay, so for the third case, okay, so let's say in the third case, when the voltage sources are connected in parallel. Okay, and they are connected in parallel. Okay, so in that case, so the two voltage sources plus minus V1 and V2 can only be connected in parallel if and only if their magnitude and polarities must be same. Okay, so the reason for that is because if the V1 is not equal to V2, it means that they are violating, so they violates your KVL, Kirchhoff's voltage law. So for that reason, in order to have a parallel connection of the voltage sources, V1 must be equal to V2. and it is also applicable for two or more than two voltage sources connected in parallel. Okay, so I hope some examples of your voltage sources are for example like batteries. Okay, batteries. Then we have like generators. Okay. Then we have like solar panels. Okay, fuel cells. Okay, so I hope it is clear. Okay, so that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.